Okay, so the solution to the given problem is as follows. The fundamental principle which would guide this particular problem would be the conservation of charge principle, basically. Which means that the charge is neither, something which can be created nor destroyed. It's already there. And how does this apply in this particular problem is that the amount of charge which would be reaching any of the junctions which are identified as these block spots would be equal to the amount of charge which would be going out of a given junction. So you can notice that there is a flow of current in to the certain junctions, and there is flow of current out of a junction, like in this case, and in this case this is the current which is moving out. So it just, what we would need to apply is the overall current entering a junction and what is leaving a junction would be equated and balanced to determine this value. So we can pick any junction and work our way through the circuit. So here let's start with this first, junction over here, and what we see is a 3 ampere current entering in and a 2 ampere entering here. So the net current which would be kind of flowing in this direction would be, let's say, 5 amps. All right. Now at this point, there would be certain current which would be coming through this channel like this over here, and it's possible that the current could be going up like this, or it's quite probable that it could be entering in and this direction is opposite. But we can always take a given direction to begin with, and and when we work it out, it should automatically correct itself. So up to this point, let's see that this is the current flowing out, let's say, from this junction. Then there would be certain amount of current which would be coming in from here, and that would mean that there would be a certain flow of current either this way, or it could be, we could assume a direction over here as well. So now what we can do is, at this junction, if you apply the conservation of charge principle, you would see that I and a 2 would add up, and that would kind of make this branch having a current of 2 plus I, something like that. And when we apply the same principle here, we get this current as 4 plus 2 plus I, which is 6 plus I over here. Now the current leaving, let's assume that it's leaving over here, and that would be 5 plus 6 plus I, or 11 plus I. Now at this junction you have one current over here exiting out and another one which is 1 amp. So all that is exiting out would be balanced as 3, which is 2 plus a 1, and that would be equal to the amount which is entering in, 11 plus a I. That makes I as negative 8 amps, meaning which that the current is actually not entering into this junction, it is actually leaving out. So the actual direction of the current is over here. This is the direction, and the magnitude of I is actually 8 amperes, and that's the particular answer.